Hey everyone, in today's video we're going to be answering a question about a particle's motion given the velocity graph. So a lot of what we do today is going to be very familiar from when we were analyzing the graph of f prime to answer questions about the original. So this is going to function in very much the same way, it's just we're using more specific vocabulary around particle motion. So the idea here is that we're looking at Waldo's velocity here. So he's moving back and forth along the x-axis, and this is his velocity. So we're looking at the graph of velocity. Okay, and so now we're going to be answering questions about his motion using the velocity graph. So we're going to go through some things that we'll be asked to find, and we're going to talk about how you would find that looking at the graph of velocity. So the first thing you might be asked to find is instantaneous velocity. Well, since this is the graph of velocity, we would just look at the y value. So, for example, if you were asked Waldo's velocity at time t equals 14, I would find that time here, and then I would go up to my y value, so I would know that his velocity is 3 feet per second. All right, the next thing we have is moving right versus moving left. Now here, I know, let's do this. I'm going to talk about moving right in purple. So moving right, I know that happens when my sign of velocity is positive. So I'm going to look for where is the velocity graph above the x-axis. That's going to tell me when the object is moving right. Now, on the other hand, if we're looking at moving left, I know that happens when my sign of velocity is negative, so I'd be looking for the where velocity is below the x-axis. So for our example, Waldo is moving to the right. Let's see, from time t equals 0 to time t equals 3. And again, because this is a first derivative, we use closed brackets. I'm above the x-axis then again from, I guess this is 9, all the way here to 19. And we won't worry about justifying here. We'll go through that in some of the other examples later in the video. So then moving to the left is where I'm below. So I am below here from 3 to 9. And then again from 19 to 20. All right, so now speed, right? We know speed is the absolute value of velocity. So if I'm talking about speed, I have to consider any values that were below. I'm going to ignore their sign and just look at the value. So I'm going to say we ignore the sign of velocity. Or we could think about reflecting negative values over the x-axis to make everything positive. So if I want to know what is Waldo's speed at t equals 5, right? When I would find t equals 5, now I know that's negative 3, so I'm going to say it's the absolute value of negative 3, which is just 3 feet per second. So I'm really focused on that absolute value of the velocity. All right, now for acceleration, here we're going to be looking at the slope of velocity. So since acceleration is the derivative of velocity, I have to be focused on the slope. So at time t equals 1, the nice thing here is I have a constant slope over the interval around t equals 1. So I have -1. So his acceleration would be that slope of -1. It's going to be feet per second over second, or feet per second squared. Okay, now with speed increasing or speed decreasing, remember we have to look at acceleration and velocity. So I'm going to say look at acceleration and velocity. So this is a lot like when we talked about where graphs of f were increasing and concave up, a question like that where we had to look both at the graph and consider its slope. So let's think about speed increasing. So for the speed increasing, I'm looking at velocity being above the x-axis and having a positive slope, or I'm looking for where velocity is below the x-axis and has a negative slope. Because remember, for speed to be increasing, acceleration and velocity have to have the same sign. So here they're both positive, velocity and acceleration. Here they're both negative. So for Waldo's speed increasing, let's see, where I'm above with a positive slope is going to be from 9 to, let's see, I think that's 12. Or I could be below with a negative slope. So I actually have here from 3 to 4. My intervals are out of order, so sorry about that. 3 to 4, and then again from 19 to 20. Now, speed is decreasing, and let's see, I'm sorry, I'm going to kind of shove this at the bottom here. These directions really should be on the next page. So let's just look at this. For decreasing, I'm going to put that down here. What that means for me now is that velocity is above the x-axis, so it's positive, but then if I'm decreasing, it means my slope should be negative. My acceleration is negative. So now we have and a negative slope. Hopefully you can see this. There we go. Or I'm going to have velocity is below and has a positive slope. Again, looking at those opposite signs. So let's see, his speed is decreasing then. Let's see, when he's above the x-axis and has a negative slope, those would be opposite signs, so from 0 to 3. The next time we have opposites, now here he's below but has a positive slope. So let's see, from 6 to 9 it looks like. And let's see, above with a negative slope. So from 15 to 17. And then he's constant for a while, and then again from, it looks like 18 to 19 would be those intervals. All right, so here's what we're going to do. We'll look at one more example and do that in the video, and then I'll save the last one for any cleanup that we need to do when we're back together in class. So these directions actually go to the next problem. So the graph we're going to be looking at is going to be of the velocity graph of a particle moving along a coordinate line. So again, this is our velocity function. We always have to make sure we're really clear about what graph we're actually looking at. All right, so let's see. So when does the particle move forward? That means when is velocity greater than 0? So when is it above? So the particle moves forward. Let's see, on the interval from, it looks like 0 to 30, because velocity is greater than 0. Backwards, right, I know is where velocity is less than 0. So the particle moves backward on the interval from, let's see, 30 to 55, it looks like, because velocity is less than 0. All right, speed up and slow down. I'm going to actually go to the side here, so I'm going to draw a line. Now, speed up, right? I'm looking for the sign of velocity and acceleration to be the same. So I'm going to say the particle speeds up now, because I have to take into account velocity and acceleration, which is the second derivative, I'm going to have open intervals here. So speeds up means the signs are the same. So I'm going to be above and with a positive slope. So 0 to 10. I could also be below with a negative slope. So from 30 to 40, because velocity and acceleration, acceleration, sorry about that, have the same sign. Now, for slowing down, and let's see, first time I'm slowing down is going to be here, where I'm above the x-axis, but I have a negative slope. So from 15 to 30. And then I could also be slowing down when I'm below, but I have a positive slope. So from 40 to 55, and again we would say because velocity and acceleration have opposite signs. Oh my goodness, sorry, that went out of the view here. Now, remind me in class, there is another way that some students have found useful for remembering this. I don't want to go into it in the video, but we could talk about that in class. All right, part B is all about the acceleration. And again, I know that acceleration is the slope of velocity. So for acceleration being positive, it means my slope is positive. So the acceleration is positive wherever I have a positive slope, so 0 to 10. And down here from 40 to 55. And we can say because velocity is increasing. So you could either say because velocity is increasing or the slope of velocity is positive. I'm sorry, there's no room here. Should have planned this a little better. So then acceleration is going to be negative. Where can I write this? Let's see if I can squeeze it in. Acceleration is negative on, let's see, my slope is negative from 15 to 40 because velocity is decreasing, or the slope of velocity is negative. All right, part C then says, when does the particle move at its greatest speed? So I have to take into account the absolute value of velocity. So I notice my highest velocity here is 60. Even if I consider the absolute value, these values, their absolute value is all less than 60. So it moves at its greatest speed on the interval from here to here, so from 10 to 15. That's when the absolute value of velocity is the greatest. Okay, now when does the particle reverse directions? Right? This is when it's either changing from going right to left or going from left to right. So this is really happening whenever it's crossing the x-axis. So the particle changes direction at time t equals, that looks like that happens at time t equals 30 minutes. Okay, then the last one is, when approximately is the particle moving at a constant speed? So we're looking for whenever my velocity graph flattens out, because it means it's staying at that constant velocity over that period of time. So the only place I see that happening is here between 10 and 15. So the particle moves at a constant speed on the interval from 10 to 15. Okay, so there is one other example in the notes, but again, we'll use that at the beginning of class to clean up any questions that you might have. Thanks for hanging in.